In this video, we will learn how to derive the supply function of a competitive firm given the production function and the cost function. The question is, consider the production function and cost function of a competitive firm respectively as. The production function is being given by like this: x is equal to a times l raised power alpha times k to the power beta, where x denotes the output, a is the total factor productivity, what we call the solo residual, L and K are the units of labor and capital employed. A denotes the output elasticity of labor, and alpha denotes the output elasticity of labor, and beta denotes the output elasticity of capital. This is the production function, standard Cobb-Douglas production function. Also, for this representative form, we are being given the cost as C is equal to W times L plus R times K. W denotes the price of labor, what we call the wage rate, and R denotes the price of capital, what we call the rental rate of capital. We have to derive the supply function of the representative form. Okay, so let's try to solve this question. So how do we find out the supply function? First, we need to find out the conditional input demands for labor and capital. Okay, to find out the conditional input demands for capital and labor, what we want to do, we want to minimize cost. Okay, that is minimize. This is the constraint optimization problem first. So we want to minimize the cost, that is C is equal to wL plus rk. Okay, subject to the production constraint. Subject to the production constraint. And what is the production constraint? That is a L to the power alpha k to the power beta should be equal to the output that is to be produced. So minimize the cost subject to the given production constraint. Now first order condition requires, and let me write it here. So what will we do? So first order condition requires that we equate the marginal rate of substitution, what we call the marginal rate of technical substitution in this case, with the input price ratios. Okay, so it implies that we equate the marginal rate of technical substitution between capital and labor, and it should be equal to the price of input price ratios. That means the price of labor upon the price of capital. Okay, W denotes the price of labor and R denotes the price of capital here. Okay, now let us see what exactly is meant by MRTS. MRTS is simply the ratio of the marginal product of labor and marginal product of capital, and we equate it with the input price ratio, that is W upon R. Okay, so as we know, marginal product of labor, and let's write it here, then I will write here, marginal product of labor is simply the change in the output due to the change in the labor employed. That is the derivative of this function with respect to L. Okay, if I differentiate this function with respect to L, the exponent of L will become coefficient. So the exponent of L is alpha. Alpha becomes coefficient. Then we have a L raised power, and exponent of alpha will be exponent of L will be subtracted by 1. So we have alpha minus 1 k to the power beta. Okay, so I can write MPL is equal to alpha a L to the power alpha minus 1 k to the power beta. In the same manner, we need to find out the marginal product of capital. That is simply the change in the output due to the change in the capital, due to the change in the units of capital employed. Okay, that is the partial derivative of this function with respect to k this time. So again, this time the exponent of k will become coefficient by the laws of the derivatives or differentiation. So beta, we get beta a L to the power alpha, and the exponent of capital will be subtracted by 1, so we get beta minus 1. Okay, can I write it here? That is beta a L to the power alpha k to the power beta minus 1, and it should be equal to the input price ratio, that is W upon R. Okay, now let me rub this out. Okay, so I will not rub this out first. Okay, let me rewrite it here. Okay, if I divide these two with each other, so that means marginal product of labor upon marginal product of capital will be equal to this thing. Okay, I'm just trying to derive, simplify it here to save the space. Okay, what happens here, and here you can see easily, I write alpha a k to the power beta. Okay, and I transpose this k to the power beta minus 1 to the numerator, so it will get multiplied, but the exponent sign will change. So if it is beta, it will becomes minus beta. If it is minus 1, it becomes plus 1. Simple law of the radicals. Divide by, here we have beta a, here we have L to the power alpha, and in this case what I am doing, so first I transpose this to the numerator, now I transpose this L to the denominator, so it will get multiplied, but exponent signs will change. So we have L, the exponent of alpha is the exponent of L is plus alpha, it becomes minus alpha. Here we have minus 1, it becomes plus 1. Okay, doing some cancellation, this gets cancelled with this, and if we simplify further this, so what happens, we will get alpha upon beta. Okay, bases are same, we can add up the exponents in the numerator, that is k raised power beta minus beta plus 1, and same logic applies here. So we have bases same, we can add up the exponents, we get alpha minus alpha plus 1, that sums up to, so we get alpha, so beta minus beta gets cancelled, we get k raised power 1, here alpha and alpha gets cancelled, we are only left with L, so we get alpha upon beta times k upon L. Okay, when I simplified this, I got alpha upon beta k upon L, it should be equal to the input price ratio, that is wage rate upon rental rate of capital. Now let me rub this out. So let us solve this for k. So k will be equal to we have W upon R here first, let me write it here, W upon R. If I transpose alpha upon beta here, it becomes beta upon alpha. Okay, it gets reciprocated and L gets multiplied. Okay, now what we do, we plug the value of k is equal to this stuff into the production constraint. That means we put the value of k is equal to this stuff here. Okay, done, 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 here. So what happens then? Then it implies we have a L to the power alpha, in place of k I write this stuff, that is beta upon alpha W upon R L whole raised power beta should be equal, or rather exponent should be equal to output. Okay, now let us what we do, let us further simplify it here. Okay, so how do we simplify? Let me simplify it here, then I will rub this. So we have a, here we have L to the power alpha. If I take this L to the power of beta here, so can I expand it as L to the power beta? Then we have beta upon alpha W upon R whole raised power beta is equal to X. Okay, here we get bases are same, we can add the exponents, we get L raised power alpha plus beta. Okay, then we have a, then we have beta upon alpha W upon R whole raised power beta should be equal to X. Okay, since we need to solve for L, so can I write it in this fashion, that is L raised power alpha plus beta is equal to, so we have x transposing this, it will get divided, that is we get a beta upon alpha w upon r whole raised power beta. Okay, so what we got here, we got L raised power alpha plus beta is equal to x divided by a, then we have beta upon alpha times w upon r whole raised power beta. Okay, let us further simplify it here. So can I write L is equal to, if I transpose alpha upon beta, it will become exponent in reciprocal order. So we will get L will be equal to x upon a beta upon alpha w upon r whole raised power beta, and it is, when I transpose, it will become 1 divided by alpha plus beta. Okay, this is the conditional input demand for labor. Now we need to find out the conditional input demand for capital. Conditional in the sense it depends upon the level of output here. Now plug the value of L is equal to this stuff in this equation. Okay, so let me simplify it here. So we have K, or let me write it here, plugging the value of this L here. Okay, we will get K is equal to beta upon alpha times w upon r, and the value of L what we got here, which is equal to, in place of L, can I write x divided by alpha, then I have bracket beta upon, so sorry, it is a here, the state of technology, w upon r raised power beta whole raised power 1 upon alpha plus beta. Okay, now let's further simplify this. Okay, so for that what I write, so K will be equal to, let us expand this further. Okay, so I'm not writing this stuff here, I will show it why. So let's expand this very stuff. So we get x raised power 1 upon alpha plus beta divided by, we have a raised power 1 upon alpha plus beta. Okay, now when I transpose this term to denominator, okay, the exponent sign of this will change, it will become -1. So it will become, and let me write it here, we have first beta upon alpha w upon r whole raised power, if I expand it, it becomes beta upon, okay, so since this is the exponent of all these terms, it becomes beta divided by alpha plus beta, and when I transpose this term, it gets multiplied, so we have beta upon alpha w upon r. Here again you can see we have the same basis, we can add up the exponents. And can I write it like this, we have K is equal to x raised power 1 upon alpha plus beta divided by a 1 raised power alpha plus beta. Okay, bases are same, we can add up the exponents here, so we will get beta upon alpha w upon r whole raised power, so here it is -1. Okay, I have just transposed it here, so we will get here beta upon alpha plus beta -1. Okay, now if I solve this and the exponent, so we have, let's write it here, we get beta minus alpha minus beta. Okay, beta minus alpha minus beta, so beta and beta gets cancelled, we are left with minus alpha as the exponent. So let me see if I have the space, I have. So can I write it like this, K will be equal to, let me write it here, that will make more sense because I don't have the space. So let us write this k, which what we got here. Let's do one thing here. So let us solve it further. So we got x raised power 1 upon alpha plus beta divided by a raised power 1 upon alpha plus beta times beta upon alpha times w upon r raised power. So when we subtract it became minus alpha. Okay, we can further simplify it. That means k will be equal to x raised power 1 upon alpha plus beta divided by a raised power 1 upon alpha plus beta. So what I do here, I reciprocate numerator to denominator. When we reciprocate numerator to denominator, the exponent sign changes. So we will get alpha upon beta, w r upon w, r upon w. And when we reciprocate numerator to denominator, the exponent sign changes. So if it is minus alpha, it becomes plus alpha here. Okay, that means the conditional input demand for capital will be equal to, conditional input demand for capital came out to be x raised power 1 upon alpha plus beta divided by a raised power 1 divided by alpha plus beta times alpha upon beta times r upon w raised power alpha. Okay, not only alpha but alpha divided by, here we have alpha plus beta. So we have alpha and alpha upon alpha plus beta. Okay, the exponent sign changes. We got the conditional input demands for capital and labor. Since we are interested in finding out the supply function of a perfectly competitive firm, okay, I will explain what is the condition for finding the supply function of a representative firm in case of perfect competition. First, we need to find out the cost function. So you will be wondering, we are being given the cost function, but here cost is a function of capital and labor. We need to find out the cost as a function of output. Okay, so we simply plug the value of k and l into the cost function. Okay, so we plug the value of k here and we plug the value of, wait a minute, what I am solving? Why it got so scary, this equation? Okay, no problem. Okay, so the value of k and the value of l is this. We plug it here. So C will be equal to, the cost of the firm will be equal to W times the value of L. L is equal to this very stuff. So can I write it like this? So expand it here again. So we get W times x raised power 1 upon alpha plus beta. Then we have divided by a raised power 1 upon alpha plus beta. Then we have beta divided by alpha w upon r whole raised power beta divided by alpha plus beta. Okay, this is w into l, plus we write r into k. The value of k which we got is x raised power 1 upon alpha plus beta divided by a raised power 1 upon alpha plus beta times alpha upon beta r upon w whole raised power alpha divided by alpha plus beta. Okay, I think I have simply made it more complex, but I don't know how it happened. there can be some more simplified version of this, but this is how do we solve. Okay, this is our cost function. So can I rewrite the cost function like this? So C is equal to, let us take x common, so we have x raised power 1 upon alpha plus beta, and let us take a also common. Okay, a, since we have the same exponent here, can we write it like this, or let's write it as it is. Okay, 1 divided by alpha plus beta, and here we have a raised power 1 divided by alpha plus beta. So what we are being left with, we are left with w. Okay, we are left with w divided by beta upon alpha times w upon r beta divided by alpha plus beta. Okay, plus we have r, so r divided by this stuff, that is alpha upon beta times r upon w whole raised power alpha divided by alpha plus beta. This is our cost function. Cost is a function of output. Now in case of perfect competition, what happens? To find out the supply function, so we equate price with marginal cost. Okay, so marginal cost is in fact the supply function of a representative firm in case of perfect competition. Okay, so profit maximization condition requires that we equate price with marginal cost. So P will be, so we also need to find out the marginal cost. Okay, so can I write marginal cost will be equal to the derivative of the cost function with respect to output. Okay, we need to differentiate this function with respect to x. Okay, so the exponent of x becomes coefficient, so we will get here 1 upon alpha plus beta. Okay, then we have x raised power 1 divided by alpha plus beta, and its exponent is subtracted by 1, and here we have this very stuff, that is a raised power 1 divided by alpha plus beta. Our choice variable is only x, and we have taken it out, so then we are left with w divided by beta upon alpha w upon r whole raised power beta divided by alpha plus beta plus r divided by alpha upon beta r upon w whole raised power alpha divided by alpha plus beta. Okay, let us solve the exponent here. So it becomes, so we have 1 divided by alpha plus beta minus 1. Okay, it becomes 1 minus alpha minus beta divided by alpha plus beta. So can I write, so what will be our supply function? So P, price as a function of output, will be equal to, so we have 1 divided by alpha plus beta, then we have x raised power, when we subtract the exponent it became 1 minus alpha minus beta divided by alpha plus beta divided by this a raised power 1 upon alpha plus beta times this w upon beta upon alpha w upon r whole raised power beta divided by alpha plus beta, plus we have this r divided by alpha upon beta plus r upon w whole raised power alpha divided by alpha plus beta. This is in fact the supply function of the representative firm in case of perfect competition, that is price as a function of output. Output is x here. Okay, so I hope I make myself clear in this video. So I'm just solving these questions for you people. I don't charge any penny for this, and I don't take any courses or any online course or offline courses. It's my hobby to make myself more useful for the society. Okay, so I hope my videos are, you know, making a value addition, what we can say, for the economics. So I simply need your you know, feedback. That is, if you like, comment and share this channel with your you know, friends. That's the only motivation for me to keep going on. Okay, so I hope you find out this video helpful. Thank you.